this talk comes from a singular question. We all learn from each other in this group, and I remember 8 years ago, Dave Hurst from Houston challenged me, and he said, you don't know your system because they're calling the hospital for medical direction, they're not calling you. They need to call you for medical direction. And so since that time, myself and the deputy medical director have taken the phone, and the medics call us for medical direction. And here was the phone call that happened all the time. We are at 30 minutes. We are still in VFET. We have given all that other up. We have an entitled CO2 value of 40. The patient is still spontaneously respiring during our compressions. What do we do next? And my answer was, we'll not know together, because I don't know either. And so we then asked the question, and we are fortunate in that SAS actually is in our community. The corporation is in our community. So we did not use SAS software. We took the data we're going to talk about to SAS and had them analyze it for us. So this is not SAS certified, this is SAS performed. So I think we're okay with the data quality. We'll prove that in just a moment, I hope. But the other thing that's been talked about here a lot is the combination between EMS and public health. Right, so I do think I need to make a public health announcement for you this morning. So, in wine there's wisdom, in beer there's strength, in water there are bacteria. Use that information wisely later today. So, here's the plan. They say just one person can make a big difference. Sometimes they are wrong. And this is not a one-person deal. This is not a one-system deal. We are using the same cardiac arrest team approach that you have heard about all morning. So these data are applicable, I believe, across systems because there's a very standardized approach, and we're all using that standardized approach. This was the paper that started all of this, and these are the data that we put in that basically showed when we did the team approach that you talked, that we just heard about, good compressions, avoid hyperventilation, add some cold fluid, you can take your odds of survival neurologically intact to about fourfold. Phase 3 is all 3 of those data. So that's the background data. But the question then is, if it's so important to work it on the scene, how long should you work it there? And that's the part that we did not find a lot of guidance, besides the paper that Paul mentioned, about beyond 20 minutes. And we knew we were already beyond 20 minutes. So here's the thing, all of the rules have in there, the termination rule, it says no ROSC. But there's no consistency about how long these patients were on the scene. So no ROSC in when? 10 minutes, 20 minutes, 40 minutes, an hour, how long do you stay? So that's the question that we're trying to answer. The rules work, we know that, we just don't know that ROSC yet. So this was the clinical question, and we know that beyond 25 minutes, anecdotally we had survivors, and the question is, can we quantify that? So SAS did a multivariable regression for us. As we said, we had the data, they had the analytics, so they did a regression to look at this, and this was presented at MSP last month. We had about 2,906 observations, and then we excluded from that patients that were traumatic, patients that were pediatric, resuscitations not attempted, if they were arrested in our control, in our witness, thinking that was somewhat different, and codes not in our control, and then we looked at the variables. These are the data divided by the different phases, and you can just see as we move through, continuous CPR, rescue pod, hypothermia, post-ROC, hypothermia, after ROC. This is just the background to make sure that the data work the way we wanted to. We're doing a little deep dive into the data, but I think that's okay. You can see that the green line there is survival by phase. So what we'd like to see is each of these interventions has improved survival. Well, that's wonderful. The next question is, did it improve neurologically intact survival? And yes, it did. So that was satisfying in the background. Now we're going to get to the main question. There we go. So for those true data geeks in the room, you want to see an ROC curve about the way that we did the models, and they modeled this 4 different ways to help control for the retrospective nature of this. And you can see that's a very nice ROC curve for the data folks in the room. If you're not a data person in the room, you don't care about that slide. So this is the part that we do care about, though. And I want to take just a moment to show what this is. And this is the predicted probability of survival based on initial rhythm as a function of time. And you can see the length of resuscitation off to the left, and in 5-minute intervals, and then come into asystole, VFET, PEA, non-shockables. And you can see that even at 35 minutes, if you are still in VFET, you have a 31% chance of survival. So this notion that we're going to stop at 20 minutes would lose quite a few. And the curves off to the right are the kind of ones that we all walk around now within our brain when we answer the phone. You can see if you're in asystole and you don't come out of asystole pretty quick, the game's over. Right? And I don't think that's not probably headline news. What is kind of headline news is that PEA, the green, looks more like VFVT than it does asystole. So they're coming into this area of good compressions, is changing the face of PEA, and it's looking more like asystole than everything else. But this is just survival. Right? What do we really care about? Neurologically intact survival. And the beauty of these curves is that they almost superimpose on one another. And if there's nothing you remember from this talk other than this one thing, I hope you just walk away with this. If you live, you're pretty doggone likely to be neurologically intact. As time goes on, you are less likely to survive. That's true. But if you do live, then your probability of being neurologically intact is pretty good. And we'll talk about the way to look at that in just a moment. But these curves help us a great deal as we start having that discussion with families and thinking about the ways to do this. This is the presentation from NMSP last month, and I'm sorry I could not get this to expand that top bar graph, but I'll tell you what the top bar graph demonstrates. That red line is where 90% of the neurologically intact survivors were captured, and that was at 40 minutes. In other words, you had to go to 40 minutes to capture 90% of neurologically intact survivors. But even those that went beyond, from 40 minutes up to an hour, they were 70% neurologically intact, with a confidence interval of about 55 to 80%. So even on the low end of the confidence interval, half of those that survived beyond 4 minutes were neurologically intact, and the point estimate is actually more like 70%. So we do believe that we can move beyond the 20-minute rule, and now we're at the point of, in our system, it's an hour. If you look good, you stay for an hour. We'll talk about the limitations in just a minute. So this is 90% of those at 40 minutes, 42 survivors, and these are the things that we had, and then they controlled for all of those variables in the background for the changes in our system. So these are independent of any of the changes that we made in the system.